Okay, so getting started with LTSpice. This will be for Windows computers here because that is what I'm on right now. So you're going to want to go to this website from analog.com, from Analog Devices. I believe we'll link this website in the assignment page, but you can also just search LTSpice download, and it'll be this first option here from analog.com. Alright, so you're going to download for Windows. Save that. And you can just run their exe. And this will just take you through a regular installation here. Of course, you probably want 64-bit executable, but it doesn't really give you an option. It does give you an option, okay. Most likely you want 64-bit. I would be surprised if anyone is using 32-bit computers. You're probably going to be on 64. So we'll install that. It's just going to go through some extracting process here. Give it a second. Great, and then when it's done, you'll just get this successful installation. Say OK, and it should launch automatically for you this first time. Of course, if it doesn't launch, just go run its exe. It is a pretty straightforward installation. It really it isn't too difficult here. It's made to be a pretty user-friendly application, unlike a lot of electrical engineering software. So we'll just give this a second to finish its first step, running instructions. Shouldn't take too long. Oh, alright. Gotta do some more stuff here. Alright, I'll check back in just a second with this. Alright, great. And here we go. So it's going to warn me the last time your installation was updated was 48 days ago. I guess that may be because I have had LTSpice on my computer before, or this might be a default message. Let's see if we have anything to update real quick. Nope. It'll be fine. I'll just say no here. Alright, great, and we are good to go. So this is what you should expect to see whenever you launch LTSpice here. Pretty basic setup there. The other thing we want to show you is using pre-made schematics. So we have provided you schematics here, so you can download this schematic. It's a .asc file. We are just going to save that. And we're also going to download this file here, which is a component file. So this is for a specific component. We are going to be using an op-amp later. You don't have to worry about what this component is, but essentially this text file tells LTSpice how this component responds and how to simulate this component. So it's pretty simple to open that program. All you're going to need to do is open your downloads folder and launch that design. You can just open that, or you may need to tell Windows to open it with Spice Simulator with schematic capture. That's what it's going to be called. The default install location will be on your C drive or wherever you installed it. So you'll go to C, Program Files, LTC, and then you'll have an LTSpice option here. And there's the exe, the XV11. If you need to manually select that .exe, but Windows is likely going to be able to auto-detect it for you. And here we have this simulation. Now, I'm curious to see if okay, so it doesn't seem to like this component, which is probably because we don't have any resistor values in there. So let's just throw some values in. I will go more in depth as to what I'm doing here in just a second, after I make sure that all of this is working. Okay, great. And there we go. Alright, awesome. So that is all that needs to be done for installing this library. All I needed to do was have the file downloaded. Now, in order for LTSpice to find this component here, we have two options. So, one option is as long as the LM324 library file, which is this the .lib file, this guy, .ti.lib, that you installed, as long as that is in the same directory or same folder as your .asc file, which is this schematic, you'll be good. So if you have those both, if you have them just still in the download directory, then LTSpice should work for you. Otherwise, if you're having issues with that, you may need to place it in the specific LTSpice library directory, which is going to be at your LTSpice installation directory, which as default is going to be your C drive and then program files. Here, I'll navigate to it here. You want to go into your C drive, program files. Again, it should be under LTC. And then here's LTSpice. And then after that, you want to go lib comp. And here's where you can install library files. So you may, if you're having issues with LTSpice, finding that schematic or that library file, you may just need to take it and copy it over into here. And I'll rename it just to get rid of that one there, because it seems like that was the second time I downloaded this. And that should work as well. Alright, great. So that is the basics of getting started with LTSpice. If we go back to our lab, which is over here, had to find which tab it's on. Gosh. We can take a look at just basics of building circuits as well. So we are going to be working with this circuit, which is not provided, I believe, as a library file here. Let's see. So we have the schematic for later. However, we do not have it for the designing a circuit section. So if you want to design this yourself, I can show you just a quick introduction to how to do that. So we're going to want a new schematic. That's this button here. New schematic or file, new schematic or Control N. And that gets us a nice blank canvas here. So this is for later. We don't need this guy. We're going to look at this draft. Now, I'm going to be basing this schematic off of that image. So I'll make sure I can have the image visible. Great. And so the shortcut for pulling up a resistor is pressing R. Or up here in the toolbar, you can select this resistor button, and that'll let you place resistors. Or there's lots of different ways you can do this. You can go into Edit, and there's a resistor here. Okay. So that lets you hover a resistor like this. If you want to go back to the mouse, you just press Escape, and that gets you back to that. So now I want to place a couple of resistors. So that first one there is rotated. So rotating is a little bit difficult. It's Control R, right? Because R is already the resistor key. So Control R will rotate it. I'll just place a resistor there. It's easiest, I find it easiest to place your resistors first and then wire them together afterwards. So I'm just kind of creating the outline of our schematic. And then we have 3 there. So 1, 2, and 3. Alright, so those are all the resistors we're going to need. Now let's wire them together. So all you're going to need to do for this is select the pen. Sorry, you can't see that. Select the pen tool here, or the wire. And now you can see we get this nice crosshair, and we can start wiring it together. So you're just going to click on one part, drag it over. I'll click again to change directions and wire in that guy. And let's get our 3 in there. And we want our 6 also. Okay. I know this doesn't look all that pretty. You can actually draw straight through components like this, and it'll fix it for you. It'll just detect, oh, these guys should go in series. Let's wire this guy up. And this guy. And now we need our bottom wire that connects everything through. Alright. Pretty pretty straightforward so far, but we're not quite done. We are going to need to place our ground. That's always important. We need to place a ground. So I'm going to place it on that bottom node there, just like it's shown in that schematic. Now the last thing we need is actually a voltage source. And it appears that we want this voltage source right here, where I have already made a wire. So that's my bad. Oh, sorry. So I will you can just grab the scissors here, cut, and I can just snip that wire. And now we're going to need a source. I believe we go under Edit. Let's see. Do they have a source here? No, they don't. So if there's a component not listed, we can click Component. That opens this window, which has a bunch of things here. So let's find. Should be under Sources, I believe. Here we go, voltage. That's what we want. And we'll put that right there. And now we'll wire it in. Alright, there we go. Now you can also scroll out with Alt Scroll, or the zoom key is here. Oh, sorry. So you can move around if you're just using your mouse, just by clicking and dragging. Alright, so the only thing that we are missing, so this matches our schematic. It's not quite as pretty, but it works. Now the only thing we're missing is values. You can see we just have blank R's here. So what we're going to do to enter those in is all you have to do is you're going to right-click it. So I'll right-click this guy, or I believe you can also double-click it. Nope, I guess you just got to right-click it. And we're going to give it a resistance here. So this one will put 1K. You can put letters here. So you could put 1000 if you want, or we can do 1K, which means the same thing. We're not going to put a tolerance or a power rating. You can put those in if you want a more lifelike simulation, but we're not super worried about that. So we're just going to call it a 1K ohm resistor. Great, and now you can see that's updated. Let's make this guy 2.2K. Awesome. This guy 100. And I'm just basing this all off the schematic that was provided. 470. 50K. And 10K. Alright, great. And the last thing is we need our voltage source to have a value. So again, right click on that. We'll give it 5. You can ignore the series resistance. We will pretend it's an ideal source, which means it has no resistance. So we say OK. Now all of our values are set up. Awesome. Great. So from here, we are going to need to run a simulation, right? Building a circuit is great, but really the power of this tool is when we can run simulations and simulate our values. So to run, there's this little running guy emoji or button. We click that. We need to give it a simulation command. So simulation command, what does that mean? Simulation command is essentially just what this simulation should do, right? So there's a lot of different possibilities here. We could do lots of different types of analysis. We're going to do a transient analysis. So that just means an analysis over time, right? Pretty simple there. So stop time, we really don't have to worry much. I'll put, let's say 2 milliseconds. Sure, why not? It doesn't really matter there. And our maximum time step will make this really small. We're 0.001 microseconds. And time to start saving data should happen at 0 seconds. So what does all that mean? Stop time means we are going to run an analysis for 2 milliseconds. Just a simulated 2 milliseconds, right? Time to start saving data means we should save the voltage and current values from our simulation immediately, right at 0 seconds. And the maximum time step, maybe I should make this a little less small. So essentially the simulation steps forward in time by a little bit every frame or every calculation. And then it will calculate all the values for the circuit and then step forward again. And it'll repeat this until it reaches our stop time, right? So our maximum time step is 0.0001 microseconds, so it's very small. And now we can let that run. It may be getting mad at me because I gave it a very, very small max time step. Yeah, it's looking like it's not liking that. So let's give it a little bit bigger time step. So in order to stop it, there's just this halt. Press that, it'll stop it. I don't know why they didn't do just a play and pause button, because that's what I would do if I were designing it. But clearly I didn't design this. So let's give this 0.01 microseconds. We still want the time step to be small, but the cost you get, right, a smaller time step you get means you get more accuracy, but of course the cost is that we have to recalculate things more times. So let's try that. Oh, and of course, in order to change this, you can see I've got this text down here that describes our transient analysis. You just right-click on that, and you can change these values in here. Alright, so let's try running this. Let's see if this gets us. It's still a little slow, but not that bad. So we got to 2 milliseconds. Our simulation is over. Now, it doesn't look very interesting yet, right? Oh, that's because I am not measuring anything yet. So in order to measure a voltage, we are just going to, so if you hover over a wire, you'll see this little probe symbol show up. And if you click on that, that's going to add a voltage probe at that point. Right? Pretty simple there. And these voltages are always done with respect to ground. So when you add a probe, this is going to be, the voltage at this node with respect to ground. So if I want to remove that, I can right-click on this and press delete this trace, and it'll go away. So let's say, what if I put a voltage node here? That's going to be the same voltage as before, but what if I only want the voltage across R3? That's a little bit of a pain, right? So in order to do that, we can click and drag, and when we release, so you can see it's a clear thing and it turns black here, now that'll give us a reference voltage around this resistor from where I started to where I let go. Right? I hope that makes sense there. And now this may be a little bit difficult for you to see just because of the colors here, but we can see what values we have. So there's not much interesting happening over time because these are DC signals, which means they don't change with time. It's just a set voltage. But we can still see what's there. So this cursor is really convenient. You can see I brought it up by clicking on this label. And it is going to tell us the vertical value there. That's what we're interested in. That's going to tell us the voltage of this measurement. So this was our green probe, which was this voltage, just the absolute with respect to ground, right? So it's looking like 2.5558 volts. And then this one, the blue voltage here, was across this too. And it's much smaller. We've got 1.24 millivolts, right? So this blue one, this was the other measurement, and that's how I opened up that probe, and I can see the exact value there. So that's pretty useful. So now we see we can measure voltage. Let's get rid of these traces, though. Not super interested in them. So that's how we measure voltage. Now what about current? Current's actually pretty simple. We are just going to click directly on a component. You'll see this little guy shows up. And so let's say we want the current here. We just click on that, and now you can see this says IR7, meaning the current in R7. Right? And if I were to click on this, we could see, oh, it's minus 42 milliamps. Interesting. That is interesting. And so that value is negative because, as you can see, the direction arrow here, where that current is pointing. So it seems to have just picked a direction. Maybe there is a way to switch that, but I am not sure of how we do that. So yeah, for now, just remember, it's assuming current is going up, but in this circuit, current is actually going to be going down. So it's going to give you a negative value in the up direction, right? Because current is actually going down. Another interesting thing to note here is when you hover over a component like this, we can actually see some details about it. So in the bottom left of the window, even before I activate the measurement, this will show us the DC operating point of this circuit, of this component. And this works because we're doing a DC circuit here. So we don't really worry about the AC signal, the signal over time. We just want to know what happens in the DC range. And so we can see that it looks like its current, according to what's in the bottom right there, or bottom left, should be minus 42 microamps. Of course, that is minus 42 going up, so positive 42 microamps going down. And if we compare that to what's on the trace, it's the exact same thing. So pretty simple there. Great. So hopefully that makes this pretty clear here. Also, a fun thing I just noticed is that you can actually, if you alt-click, you can actually measure the temperature of these components as well, which I actually don't think will be very interesting because, oh, interesting, it does give us a value for that. That is going to be its power dissipation, is going to be the measure of temperature there, which makes sense for measuring resistor. Alright, great. So the only things you're going to need going forward for this lab are going to be measuring voltage and current of different components. Yeah, in the next video I will begin to actually perform this lab and get the needed measurements. Great, thanks.